So in class today, we discussed briefly a little bit about statistical thinking. But today I want to show you a couple of the main problems that we want to look for in statistical studies, things that we can notice right away. And I sort of hinted at these today. But the first two things are number one, misleading graphs. And number two, the second thing is bad sampling or bad sample method. All right. And so, what are we generally talking about when we talk about these two things? The first one is this. A misleading graph is generally a graph that hides information in some way. So, how do you do that? Number one, you could have a graph and not start it at 0 down here on the axes. Now, in general, we often do that on the x-axis, or we have labels for categories on the x-axis. But if you don't start it, you can change how a graph looks on the y-axis. For instance, if we start the graph at 50 and go 60 and then 70, and say we're recording the stock price of some item, and say that item is $59 and then it's $65 and then it's 64 and or 62 and then it's $55 or something like that. It looks like when we look at this graph that the changes in the stock price are really large. However, if we put that graph together and we number it from 0, 10, 20, 30, 40, sorry, I got to get the rest of the graph, 50, 60, 70, and then we put those values just a little bit below 60, about halfway, a little above 60, and a little bit below, then the differences don't seem as pronounced. The peak is still there, but the differences are relative to their actual size. Another thing that students often do for me is when comparing graphs, they actually mess up the scales. So this graph, maybe they'll label it from 0, 10, 20, 30, like that. And then the next graph, it's the same data, but maybe it doesn't go as high as 30. Maybe it only goes as high as 20. So then what they do is they do 0, 10, 20 like this, and the scale on each graph is different. So if you had a graph on this scale, say a box plot, right, and then you had a box plot here, you couldn't really talk about comparing them because they're on different scales and you can't see what their relative shapes actually look like compared to each other. So that's what we mean with misleading graphs. There's some characteristic about the graph that causes issues. Typically, it has to do with scaling or missing parts of a scale or something like that. The second issue is bad samples. All right. And so what kind of thing happens with bad sampling? Well, we talked about today how they might have interviewed just 5 dentists who were in the same town where the factory was. Or they might have had a phone call bank where dentists called in, so only the dentists who wanted to talk to people called in. Or you might do some sort of random sample. So the two big problems with samples are what we want to call voluntary samples or voluntary response samples, and what's called a convenience sample. A voluntary response sample is a sample where someone chooses whether they answer or not. This happens a lot with phone surveys, a number of other things. There are ways you can minimize the effects of both of these things, but that costs money and so forth. So, just a voluntary response sample is an issue. Another, the other type of sample is a convenient sample where you just put people in the sample who are convenient. For instance, you just walk into one grocery store and you only put the employees at that grocery store in a sample interviewing working conditions at that grocery chain. And so you just pick employees at one store. That would be convenience because it's cheaper. You just interview those people. You already know they're disgruntled, so you can make your point, etc. So these are the kinds of things we look at for samples. In general, what you want your sample to do is you want your sample to match the whole population in some way. And this is why political samples, especially in this modern era of the internet, where people get a lot of their information from the internet and not the same traditional sources, it's why people are so skittish. And all of a sudden, you get a lot of voluntary response sort of bias in samples. And it kind of messes them up, and they don't quite predict the way they used to. All right, let's go on to the next slide. So here are some quick definitions of some terms that are fairly important we need to be able to pay attention to. The first one is data. What is data? Data are just observations. For instance, they could be the heights of a group of people, the weights, the eye color, the hair color, their shoe size, the number of teeth with fillings in their mouth, the number of years they wore braces, etc., etc. It's just any collection of observations. That's what data is. What's statistics then? Well, when we refer to like our class of statistics, the general word statistics, we're referring to the science of planning a study or an experiment. And there are 5 parts to that planning a study or an experiment. There's organizing data, then summarizing data, presenting data, analyzing data, and interpreting data. Now, just to help you out with this, organizing data is going to be like tables or graphs of some type. Summarizing data are going to be numerical summaries. Where's the middle of this data? How evenly spread out are things in this data? That kind of stuff. That would be summarizing. Presenting, again, that might include some kind of graphs or things that would actually illustrate the data, show us the data through graphs or tables as well. So we organize them into those so that we can then present them. And the presentation kind of follows a pattern. All right. Analyzing the data has to do with all our calculations that we're going to do beyond the summarizing ones. So this will be where we're trying to do a test or make some kind of predictions through regression models, etc. And then interpreting data is where we interpret what all of this means. Okay? And so that's what the study of statistics is. It's the science of planning a study and experiments through organizing, summarizing, presenting, analyzing, and interpreting data. All right? So, population. What's a population? The population is going to be the complete collection of data that you want to consider. So, for instance, if I label a group that I want to study. I want to study basketball players, and I want to look at the average shoe size of college basketball players in the United States. All right. Then the complete collection of every shoe size of every college basketball player in the United States would be the whole population. And a census would be that actual collection of that whole population of data of shoe sizes. All right. A sample then is essentially a sub collection. It's a smaller group of that population. So it's a smaller group of the population, and we're going to grab all their shoe sizes, and we're going to hopefully hope that that sample is representative of the population. All right. Just another word here. It's not in your textbook. We generally call it a census when we're gathering all the shoe sizes of all the basketball players who are in college. And from a sample, we generally call it a survey when we're grabbing all the data from a particular sample. Okay? So population, census, sample, survey. All right? That's how the words go together. All right, let's go to the next slide. So another way to think of statistics besides the organizing, summarizing, presenting, analyzing, interpreting is you could think about the process of the study where you prepare, analyze, and conclude. And so when you prepare for study, what are you actually doing? You're trying to figure out what do the data represent, what kind of goals do you have for your study, where are you going to get your data from, where the source, where are you going to obtain that data, and then you got to come up with some kind of sampling method. And there are lots of them, and we'll probably talk about them in future chapters. But you have to prepare for the study, you have to do these things. And this is where the mistakes are made. People decide they're going to do really, they're going to get bad samples, and they pick the wrong kind of sample or the wrong placed source for their data. And so that causes problems. So if you were going to do a study, and in our case, we're going to be reading about people who have done studies for our problems, we need to think about these things. Then when we go to analyze, this is where we do graphs and tables. All right, this is really kind of the math section, the analyze part. And we're going to spend a lot of time in class doing this. But this is where we're going to graph it. We're going to do some simple explorations of the data. That's where we find summary statistics, try to get a feel for how the data look. Are there outliers? Does it look like data is missing? Were there any problems with our sample method? So we're going to kind of analyze that. And then we're going to we're going to create confidence intervals, or we're going to do hypothesis tests, some regression analysis. We're going to do some actual calculations to try and figure out some things to decide, to get all the numbers we need. And then at that point, we're going to make a conclusion. So we then have to decide, do our results from the mathematics, are they significant or not? And so significance becomes the key idea. And in terms of significance, we want to talk about what do we mean by statistical significance, statistical, all right, and or practical significance. And so let's talk about that. And so statistical significance is when in a study you get a result, okay, the result is unlikely to occur by chance. In other words, whatever treatment you've done or whatever you're trying to study, that's caused what happened. All right. And generally, a small probability is associated with this because you would expect the normal things to happen, right? And so there'd be a high probability of those happening and a small probability that a result happens. So when you perform the statistical experiment, you see you've got this result, and the probability of that result occurring is very small, so that indicates statistical significance. Now, of course, you can massage bad data to get statistical significance, so this is not the only thing. And then also, sometimes things are statistically significant, but they're not practically significant. There's a great example in your book about this, that it was a weight loss drug, and they showed that it was statistically significant that people in a whole year would lose like 2.5 pounds of weight on this weight loss drug. And so they showed it was statistically significant. However, most people did not want to spend a year of money on this drug and following all the protocols and so forth. So it was not practically significant. And so you have to ask yourself a question like this. Even though this is statistically significant, is it going to be practically significant? And then same thing is, if it's practically significant, the statistical significance would have to show up through calculation. Okay, so this is sort of a calculation. I don't want to say practical is an opinion, but how do you feel about it in the real world? Does it make like makes a lot of sense or not? Okay, so there's those two things. The other thing that your text talks about the rest of the time is they talk about some of the problems that occur with samples. Okay, and I'll just mention these. You can read these in the text on page 7, page 7 and 8. But these topics that are pretty good would be what are called misleading conclusions. A big one is correlation is not the same as causation. And so there's an example of that in your text. I'll let you read that. Another one is, suppose you want to look at average weight of people and people report their weight. Well, most people are going to lie about what their weight is a little bit. They'll say they're 260 when they're really 270, et cetera, et cetera. And so reporting versus actual measuring. So if you're going to do a study on weight, all right, then what you need to do is actually have a scale there and measure what the weight is. All right. Couple other things. Oh, they talk about consider the source. If you want a company to do a study on how well towing insurance works, you probably don't want AAA to do that study, right? Because that's what they sell, towing insurance, right? So they call this consider the source. You don't want people to have biased sources. Particular sampling methods might not be wise, and so you want to look at the sampling method for the type of study you do. All right, that's important. And then also statistical versus practical significance. So those are kind of the ideas. Uh, the homework, these are the topics for section 1.1. You can go ahead and do that homework in my math lab. I'd encourage you to read through these things again, and you can take some notes that you want as well. I'm going to make another video. It will be posted really quick tomorrow, which is Tuesday. It should be posted somewhere around noon tomorrow. Anyway, thank you, and we'll talk about these videos and how we're going to run class using the videos when we get back together. All right, we'll talk to you later. I just made this one. I told you to read this stuff, but I made this one just in case you didn't read it and you want to watch the video instead. Okay, and we'll talk to you later. Bye.